inequalities. Inequalities basically means the lack of equality in a given expression. Let's first look at linear inequalities. Let's check this linear inequality. First, let's bring all the like terms to one side. 2x minus x will be x, and minus 5 minus 7 will be minus 12. Thus, we solved our first linear inequality. This basically tells that as long as x is greater than minus 12, the linear inequality expression here will be satisfied. Justify our claims using an example. Let's say we put x equals minus 13 into the linear inequality expression. 2 minus 13 plus 7 is going to be minus 19. And in the right hand side, let's say minus 13 minus 5, which is minus 18. Now, according to x equals minus 13, the linear expression should be minus 19 greater than minus 18. Now, this is not possible. Minus 19 is actually less than minus 18. Therefore, x cannot be minus 13 with a value that is greater than minus 12. Let's say x equals 0. 2 times 0 plus 7 is 7, and 0 minus 5 on the right hand side is going to be minus 5. Now, according to x equals 0, 7 will be greater than minus 5. This statement is true. 7 is greater than minus 5. Therefore, we have justified our claim that x will always be greater than minus 12. Example on linear inequalities. First, let's bring all the like terms to one side. Now, as you will notice, the coefficient of x is minus 2, which is negative. So, always keep in mind, when we divide the inequality by a negative number, our sign will be the opposite. So, basically, 12 divided by minus 2 is minus 6. Therefore, the sign changes and we get x is less than minus 6. Move on to quadratic inequalities. First, let's take this quadratic expression to be fx. There are multiple ways to solve quadratic inequalities. I'll be using the number line method. Now, let's solve for fx equals 0 to get something we call the critical values. I'll solve the quadratic equation and got the critical values as x equals 1 and x equals minus 3. Now, let's plot these values on a number line. Now, let's select a random value of x in between minus 3 and 1. I'm going to select x equals 0. Now, let's substitute x equals 0 to fx. That's going to be 0 squared plus 2, 0, minus 3, which is going to be minus 3. Minus 3 is a negative number. Therefore, let me label the between part minus 3 and 1 as negative with a value greater than 1. X equals 2, let's say. Now f2 will be 5. Let's repeat the same with a value less than minus 3. Let's say x equals minus 4. F of minus 4 is also 5. What a coincidence. Now, as you can see, f2 and f minus 4 are positive numbers. Therefore, let's put a label under the number line saying the values greater than 1 are positive and also less than minus 3 are positive. The question is asking us for all the values of x that give x squared plus 2x minus 3 less than 0. As you can see, that means the negative region. That is the region between minus 3 and 1. We can conclude that the range of values of x for which fx is less than or equal to 0 is minus 3 greater than or equal to x less than or equal to 1. That's it for linear and quadratic inequalities. See you next time.